So here's an interesting question. This question involves concepts from tension and strings, from pulleys, and from normal reaction. So I'll just describe the question. We have a fixed ceiling from which there's a pulley hanging. From one side of the string, there's a platform which is attached, which has a mass of small m. From the other side, there's a man who is holding onto the string, who has a mass of capital M. And this man is standing on this platform. Now what we want to know is how much force the man has to apply to keep himself and the platform from going down. And the tension in the string is T1, and naturally the amount of force that the person has to apply is T1. So we want to find out T1. 2, we want to find out what is the normal reaction between this person and the platform. So let's get down to solving this question. As usual, we'll start with making free body diagrams. So the first free body diagram that we make is around this man. So we start an isolation volume. We isolate this person over here. This comes down here and here. So what are the cuts that we made? We've made a cut in this string, which will cause a tension. And 2, we've made a cut in the contact between this person and the platform, as we have discussed in the previous video. So let's bring this person over here. Alright, now there's one string going over here. Since there's a cut over here, it's tension, so it has to be oriented along the string, so that's vertical. It has to be moving outside the isolation volume from the surface, so that's vertical up. So let's create a tension T1 over here. Similarly, we have a normal reaction at this cut. It has to be perpendicular to the surface. The surface is horizontal, hence the normal reaction will be vertical. It has to be going into the isolation volume, hence in this case it's perpendicular upwards. So we have a normal reaction, let's denote it by N. And finally we have our weight, which is a downward force of capital M G. The second isolation volume that we make is around the platform. So we make a cut over here, down. We have a cut which is the same as the cut in our previous volume, down, from here down. Now again, let's draw this platform. Over here at this cut, we'll have a normal reaction. Surface is perpendicular, hence the normal surface is horizontal, hence the normal reaction will be perpendicular to it, that is vertical. And moving into the isolation volumes, in our case it's vertical downwards. So we have a normal reaction acting over here, magnitude N. We have a tension, again it's easy to see the tension is acting upwards, so T1. And we have the weight of the platform, which is a downwards force of mg. Now all we need to do to solve for the tension and the normal reaction is balance forces in both these diagrams. So over here what we have is T1 plus N is equal to capital Mg. This is your equation 1. And from here what we have is T1 minus N is equal to small m G. This is equation 2. So just add these two equations and what we'll get is 2T1 is equal to M plus M into G, which gives T1 is equal to M plus M G by 2. And if we subtract this equation 2 from equation 1, what we'll get is 2N is equal to capital M minus small m to G. So N is equal to M minus M G by 2. So here we've solved this question. Now there's one last condition that we have to check for both in tension and normal reaction, is that they have to be always positive. So let's check for the tension. The tension is always positive because your masses are never negative. So both capital M and small m are positive, hence tension we can rest assured that is positive. But in the normal reaction, what we can see is for this normal reaction to be positive, M has to be greater than M. And this places a restraint on this system, that this system cannot hold a man who is lighter than this platform. That sounds rather counterintuitive, but that is exactly what the maths is telling us. So what happens when this man is actually lighter than the platform? Let's suppose that the platform is 120 kgs in weight and the man is only 60 kgs. Now what you can simply see is that the platform will move downwards and it will pull the man upwards using this pulley. So this person has to be heavier than this platform, which is a major restriction in this sort of a system. Please pause this video and solve this question. Solving this question should give you a good appreciation of how manually pulled lifts worked when electric motors weren't good enough.